famous pieces of literature, things that are known and well known, that are referenced that I haven't read and want to read. Right now on my own, I'm reading through Ulysses, which is by James Joyce, an Irish author, and it's dense and thick and heavy and has a bunch of really grown up stuff in it, kind of hidden in the words. Um, but it's it's a heavy book. It's probably one of the hardest books in the English language to read. Um, but another famous book is The Fairy Queen. Now, The Fairy Queen was written in the 1500s. It's one of the longest poems in the English language. Over 4,000 stanzas, over over 4,000 stanzas, 36,000 lines. So this thing is just absolutely massive. And so it's probably that they're only doing part of it. I mean, I haven't, as I said, I haven't read it, but it's one of those classic things that uh, people read and know and reference. So that's that. Uh, Anne is excited about doing this because this is, I mean, if there was anything in her wheelhouse, this is it. I mean, this is drama, this is acting on a stage, this is recitation, and putting her heart and soul into it. Um, it's it's a special skill set that not everybody has. Not everyone can feel things and say things and emote and make people feel. Um, they say it's easier to make people feel than it is to make them think. Um, Thing is it can be kind of hard to make people feel. Uh, I know I often have problems where I grab the wrong end of the stick and cause people to feel the wrong things. Um, but you know, you and this is perfect for Anne. Um, this is perfect for Anne. This is something that she's absolutely and utterly excited about. Marilla is kind of upset that Anne isn't doing more real schoolwork, but who knows? Anne mentioned her field days. So they talked about how the classes, they went out on Fridays and they went out of the classroom and they experienced various different things around and then did nature study and wrote essays about it. And that is kind of the um, more classical method. Once upon a time, you had, before organized schooling started up, you had like one teacher and a small group of students, and they would explore. The teacher would use various different things as examples of this is what you should learn with this, this is what you should learn with this. And they would go into the library and they would read the books. And the things would be explained. And it was a much more exploratory method of learning. Um, in the 1800s, Prussian method came around, and the whole purpose of the Prussian method was that everybody learned the same things, and everybody learned the same things at the same time in the same way, so that people became interchangeable, or as interchangeable as they could be. And this works pretty well for a mechanized society. It's not the most efficient way of teaching because some people learn faster than others and some people learn slower than others. So you have to go at something slower than the maximum speed. Or a number of people are held back. You aim for the middle. You give a little bit of extra help to the people at the bottom, or you let them drop out, because that was one of the things that they did back in the day with schooling was you went for however long you went. Elementary school, a lot of people dropped out after the sixth grade. So here they are, 11, 12, and they leave work, or they leave school and go to work. They worked in the coal mines. They worked as an apprentice. They worked as whatever, and they didn't do any school. And so you had this sorting of people by what their talents were, and people who were inclined to learn, um, continued learning, and those who weren't stopped after primary school, what we call grade school or elementary school. People who were better at learning continued on to secondary education, high school. Then there was universities and so on and so forth. But now this weeding out takes place much older, and everyone's expected to be in school until they're 18, which causes some other things to happen. There's a phrase that I've heard recently, which is incredibly useful way to view the world. The purpose of a system is what it does. And, I heard this recently, and this is probably something that I'm going to be repeating, so you'll get tired of hearing it. But the purpose of the system is what it does, which says that if you have a system, the purpose of it, it's what it says on the box. It's the purpose of the system is what it does. So let's say you have a system that collects water and lets it drain. Or let's say you have a system that moves water off of a hill efficiently. So you have a hill and you have all of these drains, and the drains all collect down into a funnel, and the funnel points straight down the hill. And you have other points where it collects water together, it goes straight down the hill, and other things come in at an angle and then straight down the hill. Now, you could say that this was made to drain water efficiently, which is what it does. Sort of. It gets water off the hill. But what it actually does is it floods everything downstream. So you could also say that the purpose of that system is to flood things downstream, because there's other ways to handle the floodwater, where you have it slowly meander down, where you have intermediate catch basins that have plant life growing in it, where you have other catch basins that have porous soil. So you have soil that's mixed in with a lot of sand. And what happens is that the sand and the rocks allow the water to percolate out of the settlement basin and keep the water from flooding. So the purpose of that system is to prevent flooding everywhere and to control the water. If you just angle things down the hill, that just floods the people downstream. So you could say that the purpose of the poorly designed storm system is to flood the people downstream. There are a lot more controversial things that this applies to. And once you start looking at, well, what's the actual effect versus what do people say something is for? You take a look at it. You take a look. So speed cameras. Speed cameras are a perfect example of this. So they set up speed cameras and they give tickets out to people who are speeding. And it's like, or red light cameras. Sorry, red light cameras. The red light cameras is the perfect example of this. So they set up red light cameras at stoplights. And the idea is that, if you punish everybody, then people are less likely to run the red light. Well, when the cameras were installed, they dropped the duration of the yellow light, giving people less warning. So when people came up to the light, they had less time to slam on their brakes or accelerate through the intersection. And so the accidents ended up going up when they installed the speed cameras. So the accidents increased, the revenue increased. But the stated purpose, they said they put in the speed cameras to make things safer. But the revenue increased and the accidents increased. So the purpose of the red light cameras is to make money off of accidents. Yeah. So that's one of the things. So look at the real results and not what people say it's for. This is a very important lesson. So Anne's getting better at algebra, or geometry, sorry. Anne's getting better at geometry, and she still can't do it. And for a long time, for a long, long time, I thought that's like, oh, there are things that anyone can do with enough time and enough effort. And that, um, with enough time and enough effort, anyone can understand anything. And that, okay, if I bash my head against differential equations hard enough, if I study this hard enough and I memorize the formulas for the Bessel curve and all of these different things, that if I study this hard enough, if I work at this hard enough, I will understand how it works. Well, I've been reading things recently that says that some people just are physically incapable of understanding, of processing some things. And it's not really a failing. It's like being colorblind. There are some people who can't tell the difference between red and green because the photoreceptors in their eyes are different than ours. And because of that, they see red and green as roughly the same color. And you get this sort of yellowish blue sensation. They figure there are a number of people who think that Van Gogh, Starry Night. I did the hand gesture there because I was visualizing the curve of the thing and the star in the sky and the whole thing. It was Starry Night. So I was visualizing Starry Night. And there are some people who thought that Van Gogh was colorblind because if you were to take a look at his photos, there's not much red paintings. Sorry. If you take a look at his paintings, look at photos of his paintings, take a look at his paintings, you'll see a lot of yellows and vivid blues, but not much red and not much green. And the theory is that he was red-green colorblind, which is the most common, and it's more common in guys than it is in girls. But the theory is that he was red-green colorblind, and so that's why he had such vivid yellows and blues, but not much in the way of reds and greens. So even if I will never understand differential equations, I can still do some other maths that are useful. And even if you're red-green colorblind, you can paint some of the most beautiful paintings of the world with yellows and blues. And actually, even black and white paintings can be incredible. And I've seen charcoal, or I've seen sketches done with colored pencils by a blind man. And he knows where things are. And so he can go, okay, this is 3 inches over, 2 inches down. It goes like this. And so he can trace to the edge of the paper and draw on it. And he keeps the whole thing in his mind. And it's really incredible. And there was a story that I heard. I watched a video of him doing this. And he said that one of the problems that he had was because he was blind from birth. He didn't realize that shadows weren't the color of the thing that they were a shadow of. So everybody's shadow outside is blue. So your shadow is kind of a bluish gray. He didn't realize that, and so an apple would have a red shadow and a banana would have a yellow shadow. And so everything was the shadow color was the color of the thing it was, as opposed to the color of the sky, which is another cool thing, that the color of the shadow is actually the color of the sky. So on Earth, your shadows are slightly bluish. Inside, because the ceiling tends to be white, they're gray. On Mars, the shadows are orange because the sky is orange. And on the moon, shadows are black because the sky on the moon is black. But anyway, shadows, fun stuff.